Hello guys, welcome back to the new session of Digital Electronic and Logic. In this session, you are going to learn about canonical Boolean expression. I am your lecturer, Kundan Kumar. Let's get into the new session. This session agendas are overview of Boolean expression as you have studied in the previous video, canonical and standard form, min term and max term, and few exercises. Overview of Boolean expression. A Boolean expression is composed of a combination of a Boolean constants true or false, Boolean type variables, Boolean valued operators, and Boolean valued functions. These are examples where A, B is a Boolean type variables and 1 is a Boolean constant. Boolean expression divided into the two parts. SOP stand for sum of product and POS product of sums. So this is example of the SOP and this is example of POS as I explained in the previous video. Let's see what is the canonical form. So canonical form in Boolean algebra, Boolean functions can be expressed as a min term and some are expressed as a max term. What is the min term? In min term, we look for the function where the output results in 1. The Boolean product term are known as a min terms or standard product term, while max term, in max term, we look for the function where the output results in 0. The Boolean sum terms are known as a max term or standard sum term. Let us understand with an example min term and max term. Consider this following truth table. What is the truth table? Truth table is a combination of input and inputs, or we can say an output. So A and B is input in this truth table. So let us draw a min term and max term of the given truth table. So let us understand when we talk about the truth table, if the binary variable is 0, A and B is a binary variable. So if A or B is 0, then it is represented as a complement of variable in min term, and where min term is denoted using small m, and the variable itself is a max term, capital M. Let us understand the min term. Min term, so as I told you, the min term is denoted by small m. So small m, 0 as a first, starting from 0 number or index we can say. So m0 means this one, first one. So as I told you, if the binary variable is 0, then it is represented as a complement. So in this, when we are writing the min term of this truth table, what is the binary variable of A is 0. So if it is a 0, you can see the rules, then it is represented as a complement. So that's why we are writing A complement, A prime. It is also read as A prime, because of this apostrophe is not, is nothing but negation. Now we have again B0. Again B is 0, and since we are writing the min term, so we write as a complement prime. So we are writing B prime. And it is not plus, it is a product. You can see here is a prime. So A prime times B prime. So likewise, we are going to see the next one. So in this next input combination, we have A is 0 and B is 1. So since A is 0, so we write here M1, second min term, a prime because of a is 0. So for 0 in the mean term we write a prime form, and for the non-zero we write a variable itself. So 0, so a prime times b, because it is a 1. Because 1 we write variable itself. Only for 0 we write a complement in the mean term. So next is a variable is 1 and b is 0. So 1 is not a 0, so we write variable itself a, and b is 0, so we write b prime, b complement. Next, both variable Boolean variable is 1 and b is also 1. So for m3 equal to a and b, a b we can say. So this is a mean term. So mean terms is also known as a standard product term. Let us understand the max term. In the max term, if the binary variable is 1, the binary variable is 1, you can see on the screen, then it is represented as a complement of variables in max term, and as the variable itself in the mean term. It is just opposite of the mean term. In mean term, if the variable is 0, we write as a prime, and 1 if it is variable is 1 in the mean term, I repeat, in the mean term we write as a b. But in the max term, if variable is 0, we write as a variable itself. But if it is a 1, we write as a prime complement. So let's see m, and as I told you, a max term is denoted by using the capital M. So that's why I'm writing here capital M. So M0 because of first starting from 0 index, so equal to A plus B. Why it is A not A prime? Because A is variable is 0, and when we are writing a max term of given truth table, and if you find the binary variable is 0, then we write A variable itself in a max term. But if in the mean term we write prime. So fine, I go ahead. So plus b, because b is a 0, so plus b variable itself. M1. So variable a is 0, so variable itself, and variable b is 1, so plus b prime. So let me emphasize here. Here we are writing the plus, but here is a product, because here is a mean term known as a product term, but max term known as a sum term. So we are doing the summation, but here product term we do the multiplication. So let's go next. In this next, a is 1, so we write here a prime, plus b is 0, so we write a variable itself. Next, b, a is 1 and b is 1, so both is written as a prime, a prime plus b prime. So this is a way we develop mean term and max term from the given truth table. So if you get any truth table, random truth table, and you are asked to develop a mean term or max term or standard product term or standard sum term, this is the way we develop a mean term and max term. So once you got mean term, max term, you can combine, and that is your standard product term, and that is standard sum term. Let's get into the next slide. Canonical SOP form. So canonical SOP form means canonical sum of product form. Canonical SOP form also known as a canonical sum of product, because SOP stands for sum of product. In this form, each product term contains all variables, means all variables. So these are nothing but the mean terms. We know that SOP is a product, sum of products is a mean term. Hence, canonical SOP form is also known as a sum of mean terms form. Let us understand using this truth table. So in this truth table, A, B, C is a inputs and output. F is a stand for function, so output. So this is a not using any rules, just it is a random truth table, and I have just put 0, 0, 0 and 0, 1. I can write here 1 as well. So what I mean to say, this is the truth table is given. So this truth table say if I pass input 0 0 0 and output should be 0. If I pass 0 0 0 0 0 1 then output should be 0. If I pass input 0 1 0 and output should be 0. If I pass 0 1 1 output should be 1. It's just random. It's filled. This truth table is filled. Now using this random truth table you have to find out the canonical SOP form. How it works? Let's see. So here the output F is 1 for 4 combination of inputs. I repeat, because we are talking about SOP form, so keep in mind when we talk about the canonical SOP form, we consider the 1 at output column. In this output column, we have a 4 combination of 1 as a output for inputs. So we have 1 is here. So there are corresponding min terms are, because in SOP we have a min terms, in POS we have a max term. So the corresponding min terms are for this combination of inputs, because I told you here we have a 1 as the output for this combination. So we have a 4 1 output, 1 2 3 4. So we are going to consider only the inputs having 1 as the output. Okay, so we have 1, so this is a 1. So what could be the min term of this truth for this min terms? So this would be the Boolean equations here. So we can say A complement B and C. Why? Because just now I explained in the previous video, when we talk about the min term, mean SOP, and then if the Boolean variable is 0, it is considered as a complement prime. If Boolean variable is not a 0, then variable itself we are writing in the min term. Okay, so that's why I'm going. So A complement, because in this rows, when we get an output, this could be the input to get 1 as an output. So A is 0, B is 1, so a B, C is 1, so that's why C. Let's see the next one. Next one is to get output 1, the input should be 1 0 1. For the next one, we are considering only 1 output, not 0. So what is the, when to get input output 1? When A is 1, B is 0 and C is 1, according to this given truth table. So how to draw the second expression could be here. So A, B complement C. Why? Because A is a 1, so variable itself. Since B is a 0, so B complement for 0. Since C is 1, so C itself. Let's see the next possibility. In the next possibility, we have 1 1 0 and output is 1. So the next min term is A B C complement. Why? Because A is 1, so variable itself. B is also 1, so variable itself. And C is 0, so C complement. Look at the next possibility. To get 1 as an output, all three inputs should be high according to this given truth table. So 1 1 1. So what could be the min term for this row? So min term could be here ABC. Why ABC? Because A is A, B is also A, and C is also A. So if it is A, we write variable itself. So this is your min terms of canonical SOP form from given truth table. So this truth table was just randomly given 0101 and output is this one. Fine, so let us go and see. So now by doing logical OR is a capital letter, so you are doing the OR operation of these four minterm, these four, 1 2 3 4 minterms, we will get the Boolean function of output f is this one. How? So we have a m0 because of minterm, we denote minterm as a small letter, so m0. Why? Because the first one start from 0. So m1, m2, m3, m4, m5, m6, m7. So at which you can see the we are getting one as an output at m3 and at m5 and at m6 at m7. So we can say function, this function. So we'll just pick the minterm of this truth table. So m3 is getting as 1, m5 as a getting 1, as you can see here. These are minterms, plus m6 and plus m7. So if somebody asks you write the canonical SOP Boolean expression, just write m3 is nothing but this one, because because 0 1 1, so a complement b and c, so we can write a complement b c plus m5 is this one, so a b complement c plus m6 is this one, so we can write plus a b c complement plus m7 is this one, a b c. That is your canonical SOP Boolean expression. It can be written as a formula here. F, we can say here F equal to this field. This is sigma. Sigma means stand for here is called the summation. Summation, why? Because plus plus plus, it is a plus plus plus, so it is a summation of m is a small because a small mean term, then 3 5 6 is this one, 3 5 6, these are index, so this one can be rewritten as a in this equation. Let's go into the canonical POS form. It's also known as a POS form. Canonical SOP form, sorry, it is not SOP, my mistake, POS. POS form means canonical product of some form. Product of some form, POS. In this form, each sum term in the POS product term, but in the SOP product term, but in POS sum terms contains all variables. So these are nothing but the max term, max. Hence, the canonical POS term is also known as a product of max terms form. Let me make you understand the canonical POS form using this truth table. So this truth table is the same as previous one, but in using this same truth table, I am going to develop and I'm going to find out the canonical product of some Boolean expression. So how? It is a POS. So here the output f is 0 for 4 combination of inputs. So to get output 0, we have a 4 combination, like how we are getting output here, here and here and here at this input combination. So let's see. So the corresponding max terms, not min term, max term are for this input combination. We have product. So what could be the max term of this input possibility? So it could be here a plus b plus c. I repeat, because it is a product of sum, we are going to do the sum. Okay, so that's why we are plus plus. Okay, so I repeat, since it is a max term, in the max term, if Boolean variable is a 0, be write as a variable itself. But in the POS, if but in the SOP, if Boolean variable is a 0, be write as a prime. So don't forget about that one. Okay, so since I'm teaching you POS, so if Boolean variable is a 0, be write variable itself. So like that. So b is 0, so b plus, then c is 0, then plus c. because it's a product of sum, so we have to write in the plus plus plus. Let us see in the next combination. In the next combination is 0 0 1 0. So what could be the max term of this input possibility? So it could be a plus b plus c complement. This is because a is 0 as I explained you, and b is 0, so we are writing variable itself. But since c is a 1, and we have to write a complement form, so all are in the plus plus plus, not in the ABC product, in the because we are in the POS. Let us see the next one. So next one is 0 1 0. So we are writing the POS max term for this one is 0. A is 0, so A. B is 1, so complement. And C is 0, so C. So A plus B complement plus C. The last one is 1 0 0. So the max term of this one is A complement, because A is 1 and B is 0 and C is 0, that's why plus B plus C. So these are a corresponding max terms of these given truth tables. So by doing logical AND, in the SOP we were doing logical OR, but here we are doing the logical AND of these max terms. So we are going to do logical AND operation on these max terms. Okay. So we will get the Boolean function of output f equal to, because m is 0, then m1, m2, m3, m4, m5, m6, m7. I repeat, here also I'm reading m, but look at this, it is a capital because of max term. So min term denoted as with small m, but max term is denoted with capital M. So this can be rewritten as a f is a function, this one equal to what? Here the output of f is 0 0 0 0 for 4 combination of inputs. So we'll pick only max term of this is a max term which produce 0. So m0 produce 0, m1 is produce 0, and m2, and then m4. That's why m0, m1, m2, m4. Okay, why it is not plus here? Because of ANDing, it is a product of sum. So this is your sum form, this is your sum form, this is your sum form, this is sum form, product of this one. So this can be rewritten as a plus b plus c bracket multiplication, because again bracket open, then a plus b plus c complement bracket close, again bracket open, a plus b plus a plus b complement plus c bracket close, again bracket open, a complement b plus c, because m0 is this, m1 is this, m2 is this one, and m4 is this one. So this can be rewritten as this one. If this is the one formula, here you can see here is m is a capital because of m is a max term. Then we have bracket 0 1, this is index 2, and this 4. Fine. So this was a canonical POS form. Let's see the next one. So now we are going to convert the random given Boolean expression into canonical form. So canonical form, also known as a standard form. Okay, so let's see. Convert Boolean expression into standard SOP form. I repeat, not only standard form, standard product term, standard sum of product term. So let's see here. This is an example. So you can look at this. When you look at this one, we can say this is a Boolean expression which is in the product AB plus B complement. So we are going to convert this Boolean expression into standard product term. Okay, standard product term, or canonical form. Canonical form means all variables should be there. So you can look at this how to solve. So one step by step. To solve this one, to convert into the canonical form or standard SOP form, you have to first identify the domain. What is the domain? Domain is nothing but number of unique variables in Boolean expression. So this is a given Boolean expressions. What are the variables available in this given Boolean expressions? So complement here, and b and b complement consider as a one variable. These are not two different variables. Okay, so because we can say therefore a and b is two variables, so the a and b are a domain of this given Boolean expression. I repeat, b and b complement is considered as a single variable because both are b. So what is the next step of the conversion? The next step say find the missing variable in min term. So this a b is a min term and b complement is another min term. Why? Because of it is a SOP form. Okay. So now we are going to say that in AB min term, in AB, because A and B is a min term. Why? Because it is a product term. That's why it is a min term. No missing variable is there is no variable is missing. Why? Because as a how many variables in your full Boolean expression? You have a and b. Total a and b is a variable in this given Boolean expression. So in this min term, a and b both are available, so no variable is missing. Let us see in the next min term, this one b complement. But in the b complement min term, a variable is missing because a is missing. You can see it doesn't matter a complement or a, but a is missing. So next step say convert into standard SOP form. Since we identify the domain, we identify the missing variable in the min term. Now we are going to convert those min term which is a missing variable into standard one. So how? So as in the b complement min term, a variable is missing. So what we need to do? Hence, b complement is a already available in your Boolean expression. What is the missing? A. So since variable a is missing, we will multiply. We will do the and operation here times. I will tell you why. Why we are doing and? Because it is a b complement times a plus a complement. So why we are multiplying with a plus a complement? Because since we know that a plus a complement is equal to 1, so it is a 1, it is a 1. So when we multiply any number with 1, the resultant value will not change. So that's why this is rule we are applying here right now, because this is variable we are missing. So for missing variable we use this formula. So a is missing, that's why a plus a complement, and it is also a plus a complement is 1. When we multiply 1 with b complement, this will not make changes. Okay, so let's go ahead. Next, what the next step? So we, after applying the a plus a complement, we will use distributive law. So we are in distributive law, we are going to multiply. So when you apply the distributive law, you are going to do b complement. So we are writing in the order a b complement. Then we are going to multiply with this a b complement a complement. So we are writing a complement b complement. I'm sorry, it should be the b complement, my dear students. Here b complement. So please, when you are doing the exercise, please write here the b complement, because it is a b complement. It's my mistake. So now we can say here, so because of distributor, so now we got it, because you can see this min term also have a full variable, means a and b is there, and in this min term also have a all variable. So both variable become a now canonical form. Okay, so let us go next. Combine all the min term. So how will you combine all the min term? The one min term is ab, which is already canonical form. Okay, we can say in min to say, so none of the variable is missing, that I mean to say. That's why one is AB, so I'm writing here AB. And then from the missing one for B complement, we got the new one, AB complement plus A complement B. So we are writing AB complement, A complement, and B complement here. So please, when you're writing the practice, please write down here the B complement. Okay, so you can see in this min term, all variables the AB is there. In this min term also AB is there. In this variable AB also there. So these are the two variables in your given Boolean expression. So you have combined. Fine. So when you are doing this one, and if you find you have many min terms, it can happen that might be the AB is repeating. So when you are repeating, remove 1. So you write, because you can say if you find duplicate after combining, remove 1 since a plus a equal to 1. So if you find ab plus ab plus ab, so many times, so you can replace with single ab like was, or you can find a b complement, many times you can replace with a b complement, because according to Boolean algebra a plus a equal to 1. So this was for the standard to convert into the standard SOP, or we can say canonical form. Okay, canonical SOP form we can say. Next, let us see the next example of POS form. So in this one you can see the expression is different, a plus b plus c and times b complement plus c. So we are going to convert into the POS, canonical POS form. Okay, so let us see here. In the first step, say it is a identify the domain. Rules are same. So we are going to identify the domains. I know what is the domain. So in this given Boolean expression, the domain is ABC. Domain is ABC, and here also B complement plus C. I know that B or B complement both are known as a single variable. So we have A, B, and C variables are domain in this given Boolean expression. So next step, say find the missing variable in max term. These are a max term plus these are max term. So how to find it? You can see in the A plus B plus C max term, no variable is missing, because in this all variables are available. But in B complement plus C max term, A is missing. So now let us go to the next. We can say convert into standard POS form. So to convert, as in the B complement plus C, in the B complement plus C max term, A variable is missing. So in this one, because of POS, we are not going to multiply, we are going to the add. So A dot plus A complement, sorry, A times A complement. I know that we are doing the plus, we are not doing sorry, if you are doing the plus and you are doing A plus A complement, it's wrong, because you know that you are doing, since you are doing the plus, why we are doing the plus? Because of POS form. So plus, so plus doing in the previous one we were doing the multiplication because of SOP form. So we are doing the plus, and the rules are A dot A complement. We cannot do A plus A complement because it is plus. When you do the A plus A complement, it's become 1, then the value will change. So because of plus, we are doing A dot A plus A complement. So A, since A dot A complement equals 0, so when you are adding 0 with any number, it will not affect the result. That's why. So let us go next. By applying the distributive law, when you apply the distributive law, go and look at the Boolean algebra distributive law and see this equal to this can be done. So applying these formulas that you have learned in the distributive law, and even I have derived this distributive law equations. You should go and recheck again, and you will understand if you have missed it. So I'm applying the distributive law by using this rule. You can get it A plus B complement plus C plus A complement B complement plus C. A complement plus B complement plus C. So after applying this formula, you will get it. So now combine all the max terms. So you have a max term is this one. This is also max term. This is also max term. Now you can see in this max term, none of variable is missing. We have ABC. In this max term also none of variable is missing. So ABC. So we can combine also this one and this one, because this is a we got this max term from this max term. Okay, so we combine all. So we combine A plus B plus C times A plus B complement C times A complement plus B complement plus C times. So this is your standard POS form, or we can say canonical POS form. Not only standard form, okay, standard POS form, canonical POS form, because of product of sum. So this is a sum term, this is a sum term, this is a sum term, and this is a product multiply. In the same, if you find the duplicate after combining, remove 1 since A times A equal to A. Now, based on this explanation, you can do the self-assessment. So self-assessment is a 1, 2, 3. You can try yourself. But after doing this, you have assignment to do. Assignment to do is convert the Boolean function f equal to a plus b, ab complement into product of max term. Keep in mind, it is a product of max term. In the given Boolean expression is in the SOP form, but I am asking the product of max term. So please do a small research how to convert the given is the canonical SOP form into canonical POS form. So it is not as you are thinking. Okay, so please do the research on this one and how to convert from a canonical uh, SOP form into the canonical product of max term. Then will get the answer. This is a little challenge I'm leaving with you, so you can do small research and complete these assignments, and then you can send to me. Thank you guys. This is the all about for this session. Have a blessed and safe